Hey students, this is lesson 5.4, medians and altitudes. We're going to learn how to identify the properties of medians and altitudes of triangles. Go ahead and do the review here, some important definitions. I'll check back with you. All right, theorem 5.8, concurrency of medians theorem. The medians of a triangle are concurrent at a point, which is called the centroid. Another one of those words you need to know of a triangle that is 2/3 the distance from each vertex to the midpoint on the opposite side. For any triangle, the centroid is always inside the triangle. So DC is equal to 2/3 of DJ. EC is equal to 2/3 of EG. So this is actually times. And FC is 2/3 times FH. All right, so let's use that information to try and solve some problems here. So SP is 16, this is 16. And we know that SP is equal to 2/3 times SM from the theorem, concurrency of medians theorem. Okay, and we know that SP is 16, so we'll substitute that in. And so to solve this, let's just multiply both sides by 3/2. And we get 16 times 3 is 48, divided by 2 is 24, is equal to SM. All right, you try that. All right, an altitude of a triangle is a perpendicular segment from the vertex of one triangle to the line containing the opposite side. The altitude of a triangle can be inside or outside the triangle. Here is an example. Is AC a median or altitude or neither? So AC connects a vertex to the midpoint of the other side. That would be a median. AE is a perpendicular segment from a vertex to a line containing the opposite side. Notice it's a line containing. It doesn't necessarily have to be the actual segment on the triangle. So that would be an altitude there. All right, you try that. All right, concurrency of altitudes. A line that contains altitudes of a triangle are concurrent. Point of concurrency is the orthocenter of the triangle. The orthocenter of a triangle can be inside, outside, or on the triangle. So we're going to draw an example of each type of triangle on the coordinate plane below. I'll help you draw those, and then you can go ahead and try and do an acute triangle. So we need one acute angle. Or 3 acute angles, sorry about that. So something like this, that would be an acute triangle. An obtuse triangle, we need one angle that's greater than 90 degrees, so maybe something like this would work. And then to be a right triangle, we can just connect through there. And then just these 2 points. All right, so go ahead and see if you can decide where the orthocenter is going to be on each of these. All right, so we're going to find the orthocenter here. Now, since all 3 altitudes are going to meet at one point, we really only have to find 2 of the altitudes. So we're going to try and find the ones that are easiest. And let's start with a perpendicular line from DF to E. That one's not too hard. Go ahead and draw that in right there. Okay. And then we need one other altitude. And so let's go from D, from the vertex D to EF. And that altitude, we're going to need to know this slope to help us find that. And this slope appears to be -2. So we need to have a slope from D of the opposite reciprocal of -2, which is 1/2. So from D, if I drop a line that has a slope where I go up 1/2 like that, those two lines will be perpendicular. So this is the perpendicular line right there. So that's the orthocenter. So I don't need to find the other one because I know all three of them are going to be concurrent. So my point of concurrency is right there. That's the orthocenter. And that point is, let's see, that would be 5, -1. All right, you practice that. All right, here's a quick concept summary. And then you can go ahead and do the lesson check, and we'll talk about it when we meet in class next. So you're going to want to fill in the words altitude, angle, bisectors, medians, perpendicular bisectors, describe the intersecting lines in the triangle below. Go ahead and do that, and I'll check back with you. All right, that's it for this lesson. I will see you in class.